So if you heat a substance, it's going to change its temperature. But how much the temperature changes for a given amount of heat is going to vary. I don't know about you, but my parents used to take us to Golden Corral when I was a kid. And you get this plate. We probably shouldn't talk about this. It's getting close to lunchtime. You get this plate, and it's got a steak, and it's got baked potato, and Texas toast, right? Just like meat and carbs. That's all it was. They were all hot when they came out. But one of those is going to stay hot for a really long time, and one of them is going to cool off pretty quickly. Which is the thing that gets cold fastest? The toast, the baked potato, or the steak? The toast. The toast cools off very quickly, right? And that baked potato stays hot forever, right? Because they are composed of different substances. The baked potato has a lot of water in it, and water has a very high specific heat capacity, meaning that it doesn't change its temperature very much when it gains or loses the same amount of energy as something like the fairly dry bread. That's going to heat up more quickly, and it's also going to cool down more quickly. So the term we use for this is heat capacity. It's the quantity of heat needed to change the temperature of a given substance, a given amount of that substance, by 1 degree Celsius. So if you have a high heat capacity, it means in order to increase the temperature by 1 degree, you're going to have to put a lot more heat into it. Something with a low heat capacity, you put the same amount of heat in, it's going to heat up much farther. It's going to have a bigger heat increase. That didn't come out well. So that's heat capacity. That depends on the amount of substance, and so that makes this not as useful. So what we usually talk about is a specific heat capacity, also sometimes just called specific heat. And that's the amount of heat needed to change the temperature of 1 gram of a substance by 1 degree Celsius. And so then it's, okay, we can compare these now because we're talking about 1 gram of each substance instead of having to talk about, well, what's the mass of that one and what's the mass of this one. So the unit of the specific heat capacity is a joule per gram degree Celsius, which seems like kind of a messy unit, right? Joules divided by gram times degrees Celsius. Water has a very high specific heat capacity. This table gives us a list of specific heat capacities for some common substances. These are given in terms of joules per gram degree Celsius. And we've got lead, gold, silver, copper, iron, aluminum. These are all metals. Metals tend to have very low specific heat capacities. That's one of the things that makes them useful as cookware, right? When you have a pot, you want the pot to heat quickly and transfer that heat to what's inside of it. You don't want it to take forever to get hot. Water has a very high specific heat capacity, which means it takes a long time, a lot of energy to heat it up, but then as it cools down, it also releases a lot of energy. You do not need to memorize any of these numbers. You may need to refer to them on doing homework or worksheets or something, but I'll give those numbers to you on an exam. The high specific heat capacity of water has a huge influence on climate. If we think about the average high temperature in August, I looked these up. In San Francisco, the average high temperature is 66 degrees Celsius in August, right? In Fresno, the average high temperature is 96 degrees Celsius. That sounds more like August, doesn't it? We think 96 in August is actually quite pleasant, right? It's better than 115. Why is there this difference? The closer to the equator, the warmer the climate. But San Francisco and Fresno are roughly the same distance from the equator, so it's not that. Fresno is located in a natural desert. There's very little water around. San Francisco is on a peninsula surrounded by the ocean on one side and the San Francisco Bay on the other two sides. It's just surrounded by water. That huge body of water moderates the temperature. So where does the heat come from that makes it 96 degrees or 105 here? Where does that come from? From the sun, right? So the sun shines down and things heat up. Well, the same amount of sunshine here or in San Francisco is going to get hotter here than it does there. Because here there's very little moisture to absorb that energy. In San Francisco, that sun shines down on the bay and on the ocean, and the water takes that heat and it warms up, but not very much. Dry dirt, dry sand, dry air, the temperature will increase a lot higher because the specific heat capacity is lower. And then what happens after the sun goes down, that source of heat is gone, then you've got all this water here that's slowly going to cool down. As it cools down, it releases the energy back into the atmosphere and moderates the temperature. In San Francisco, it's pretty common to have like a 10-degree temperature change from the high of the day to the low of the night. And here, it's not uncommon to have a 40-degree temperature swing, right? You go out in the morning early, and it's freezing, and by the afternoon, you're wishing you could take all of your clothes off, right? It's just hot. So this high specific heat capacity of water has huge impacts on many aspects of our life.